A tank of water is in the shape of an inverted cone and is leaking water at a rate of 35 cubic centimeters per second. The base radius of the tank is 1 meter and the height of the tank is 2.5 meters. We're asked to find when the depth of water is 1.25 meters, at what rate is the depth changing, and at what rate is the radius of the top of the water changing. So I drew a little illustration here of our tank. It's a cylindrical, conical tank. We know that the height is 2.5 meters and the radius at the base is 1 meter. We're asked to find at what rate, when the water is 1.25 meters, as I drew here in pencil, at what rate is that depth changing, and at what rate is the radius changing. We know our depth, which I am using the H in green for that in our formula. And our radius, to get that, we take the ratio of our radius of the cone at its base to its height, and we multiply that times the height. So the ratio is 1 over 2.5, which is 0.4, and multiply that times our height, or our depth, which is 1.25 meters. Or in the case of this problem, I'm going to be using centimeters, so I convert everything to centimeters. That's 125 centimeters times 0.4, and that gives a radius of 50 centimeters when the depth of water is 125 centimeters. Now we can use those values to put into our formula, and to get these rate values, we're going to be taking the derivative of the formula for the volume of a cylindrical cone, which is 1/3 pi times radius squared times the height, or the depth. And we're going to be using the values we now know. So when we take the derivative of that formula, we get 1/3 pi times radius squared times what we're looking for, which is dH over dt, or the rate of change of the depth, plus the depth times 2 times the radius times the other thing we're looking for, which is the rate of change of the radius. We know that the rate of change for our cone with water in it right now is negative 35 cubic centimeters per second. It's negative because we know it's losing, it's dripping, it's leaking water. So we set that value equal to our equation. So we have negative 35 equals 1/3 pi, and we plug in our values that we now know. Our radius is 50, so 50 squared times dH over dt, plus our depth, 125 centimeters, times 2 times our radius, 50 centimeters. And in order to get, in order to find our rate of change of the depth, we're going to convert this dr over dt into dH over dt, because we're looking for dH over dt. And the way we do that is we can say that the because our radius is 0.4 times our depth, the derivative of our radius in relation to time is equal to 0.4 times the derivative of our depth in relation to time. So we use that in place of dr over dt. We use 0.4 times dh over dt. In doing so, we're left with negative 35 equals 1/3 pi times 2,500 centimeters. That should be times dh over dt plus 5,000 centimeters times dh over dt. And when we combine like terms, we get 7,500 times dh over dt. Continuing on, in order to get rid of that fraction, we multiply both sides by 3. So negative 35 centimeters becomes negative 105 centimeters times or equals pi times 7,500 centimeters times dh over dt. Now we can divide out pi times 7,500 in order to get what we're looking for, which is the rate of change of the depth when the depth is 125 centimeters, and that equals negative 105 centimeters divided by 7,500 centimeters times pi. And that comes out to be approximately negative 0.00446 centimeters per second. And I wrote that down here. When the depth of water is 125 centimeters, the rate at which the depth is changing is approximately negative 0.00446 centimeters per second. In order to get our rate of change of the radius of the top of the water when the depth is 1.25 meters or 125 centimeters, we can simply plug that value we just found into this. dr over dt equals 0.4 times dh over dt. We just found dh over dt, so we multiply that times 0.4, and that should give us the rate of change of the radius of the top of the water up here when the depth is 125 centimeters. And that comes out to be approximately negative 0.001782 centimeters, and that should be per second, which I did indicate over here. Approximately negative 0.00178 centimeters per second. And this probably wasn't necessary, but I did it anyways just to confirm the rate of change of the radius. So I basically just plugged that. Instead of looking for dh over dt, now I isolated dr over dt. So in doing so, I ended up, you go through and do the same process, and I got the same value, which is negative 0.00178 centimeters per second, which I guess I could write here too. So that's all I'm going to do for this. That was probably my 12th or so try on this video. I apologize if the lighting is crappy and I'm moving it around, the paper around too much, but it's hard to tell how well this is showing up with this lighting. So anyway, that's all I'm going to do.